This is a talk on technical testing. Because I'm a test consultant. That means I come into sites, I test things, and I help people test better. And one of the ways I do that is by helping them enrich their models of their application and their models of their testing. Now, throughout this talk, you will see a couple of images that, like this, that look like books, and they're based on self-help books from the 30s, 50s, 60s, and 70s, because I love the covers. I love the promises that they give people, and I love the fact they're all about helping yourself. Because ultimately, the only way you're going to improve your testing and your testability is by doing the work yourself. And you have to make an effort to do that. So whilst each of these books has promises on them, I'm not necessarily going to guarantee the same promises. So I'm not going to necessarily say you will think more effectively, but you will test more technically. Now, what I'm going to do in here are show the kind of models that I have for how I approach increasing my technical testing. So I'm going to start with an example of how approaching an application from a technical perspective helped. And this wasn't even testing. Right? I was on an online conference where they were streaming the keynotes. They had quizzes. They had a vendor area where you could see the tools. And I accidentally did a quiz. But I didn't want to do the quiz, so I stopped out early. And that would have been fine if my really bad score on the quiz hadn't been shown on a high score table for everyone else to see. So I thought, under those circumstances, I'll do what any tester does and try and cheat the test. So I got an HTTP debug proxy up and started running their online system through the proxy. Started doing the quiz again. And then I noticed in some of the traffic that my email address was in there and my name. That's okay. But my home address was in there and my phone number. I was less happy with that. And then I noticed that it wasn't just mine. There were 20 other people who were listed. So then I had a look at that request in more detail and then sent it back to the server, asking not for 20 people, but for 400 people. And then I got 400 people back. And then I thought, well, I'll change this to 700 people. And then I got a list of all the people that had registered for the conference, all their names and addresses and emails and phone numbers. So I reported that to the conference organizer. They reported that to the people that had built this software. This is software that is used not just in this conference, but lots of conferences online around the world, lots of online meetings. And they fixed it fairly quickly, which is good. It's good to see a problem get fixed in a couple of hours. But this was just me, not even testing, just observing traffic, because I can observe things at a lower level. And I found a problem that the 600 other testers in this conference did not see, that the other people who have been in other conferences with this software did not see, that the people who had tested the software in the first place did not see. And it's a fairly serious security issue, even though I didn't do any security testing. But I get lucky like that because I expand my luck by observing systems in different ways, by using the thought processes for technical testing that I'm going to explain in here. So we should start with testability in general, right? Because I'm really going to talk about testability. But testability is a word that we use. And we should understand what it is. And for me, testability is expanding the requisite variety of the system to support testing beyond that required by the user. And what that really means is we are changing the system so it can handle more variety than a user would give it. Testers do more to systems than users do. So we need to have more visibility into the application. We need to see the logs a lot easier. We need to have hooks in so that we can automate the system. And we're changing the responses the system can have. And if you take anything away from this talk, what I'm hoping that you'll take away from it and investigate in more detail is the notion of requisite variety. Requisite variety comes from cybernetics. And it basically means whether we can handle the input we're given. Now, when we test, we're exploiting variety. Stafford Beer up here describes variety as the total number of possible states of a system or of an element of a system. When I'm testing something, I really want to try and push it into states that other people haven't pushed it into. Error states, states that we're not necessarily expecting, possible states. Not necessarily the states we've expected it to have. So states where we've got valid data on the input field, but it's shown me an error message. States that we wouldn't necessarily predict, but states that the application can put itself into, that our normal testing process wouldn't cause to happen. Because anytime we find a bug, really what we're doing is we're putting the system into a state where it hasn't got the requisite variety to handle our input. Now, requisite variety was created by Ross Ashby, and he described it as only variety can destroy variety, which means when we give additional variety into a system as input data, only the system's ability to handle that variety can stop it killing the system. Stafford Beer talks about it in terms of absorbing variety, because he was concerned about how requisite variety would be handled in systems of people and organizations. And he thought that absorbing variety was much better than destroying it and killing people. So requisite variety for me is one of the things that underpins how I approach testing. I'm constantly trying to expand my requisite variety and the input I can generate for systems, and whether I can handle more systems, and whether I can test them in more detail. That for me is one of the key things that I try and do. And I've generalized the notion of requisite variety into a model of testing that I'm going to show you later on. So we all know about testability, our ability to test. This is normal. I take it for granted that anyone who does testing has the ability to test. We understand the techniques we're using. We have strategies. We know certain tools. We read blogs and books. We expand our knowledge. Our domain knowledge is of the testing world. There's a whole bunch of testing knowledge in the domain of testing that I expect us to understand if we have the ability to test. When we do technical testing, I'm expecting a slightly different set of knowledge. I'm expecting us to expand our knowledge. This is building on the kind of stuff Janet was talking about this morning. So we need to understand the technology that we're testing. We need to understand that in different ways. We need tools that will allow us to explore the technology specifically. Key things in here are modeling, our ability to model the systems and understand them. Super key thing is systems. Everything I do is based on systems. Although I say I'm a test consultant, really I'm a systems consultant. I understand systems. I understand the systems of development, the way we develop software, the systems that we use for that, the systems of the people who test the software, the subsystems. Everything that I do ties back to systems and cybernetics. And you can see technical risk is on there. Because the more that we understand the technology, the more we understand how the technology interfaces with itself, the more we can work out whether the technology we're using adds risk, whether the way that we're approaching this adds risk. We can test at a much lower level and go beyond just requirements. We can target technical risk in the system. And I've got programming there on the side, not because you have to program, but because if you can, then you have the ability to build tools and systems that will help you explore your technological system in more detail. It's a useful add-on. And for me, technical testing is a reminder to go deeper into the system. So I'm always thinking, am I testing at the surface structure, or am I going into the deep structures? Am I testing just at the GUI, or am I going and testing beyond the GUI? I have to keep that in mind all the time. Because if I only test at the GUI, I would never spot problems like messages that have all the users embedded in them. The GUI lies to me. And I'm always wondering, am I testing from technical risk? Or is this all driven by the domain risks that we've identified, the business risks? I always want to be going deeper in the system. And even if I'm not testing at deeper levels in the system, I want to be observing at more deeper levels in the system. Now, when we talk about these things, or if you decide you're fairly technical and you want to introduce more technical testing in your organization, you will encounter these limiting beliefs. People will say they're not technical. They already have testing skills and that should be enough, or they don't have enough time to learn this or do this stuff, or because we're focused on technical things, there might be a danger of missing other more important things. And these are limiting beliefs. They're beliefs. They're completely valid. It's perfectly valid to hold these beliefs. But when you do, they limit your approach to testing. If you believe you're not technical, you will never expand your technical knowledge. You'll never test the application in a more detailed way. There is a danger of missing things. You saw that all the other testers had missed that technical problem because they were focused at a higher level. I found that problem not by testing, but by observing. I see no danger in adding an ability to observe and expanding the variety of observations I can make as I test in a normal way. Now, what's really hard about this is that there's so much we could possibly do, right? But we want to make sure that we're not limiting what we do. And I don't really want to have to rely on other technical people on the team, partly because then I have to be nice to them. But I'm nice to them not because I want to be nice, I'm nice to them because I want them to do something for me. I don't particularly develop the social skills. I don't particularly develop the soft skills. I like to work on teams with peers where we're all doing as much as we possibly can and expanding our benefit, where we can have people go on holiday and not have to rely on them. It's like someone who's got a pickup truck and you want to move a sofa. You have to be nice to them so they will help you. I'll steal their pickup truck. Right? So our technical world changes all the time. Here are some buzzwords. Some of these are systems that we're working on at the moment. We've got Docker, we've got Hadoop. I had to work on Hadoop recently. But our technical world changes. I mean, it's a massive thing when we start looking at what technical skills do we need, what technologies are we going to look at. It's huge, and it continues to change. Now, I don't know all of these in detail. I've worked with some of them. If I was working with them in more detail all the time, I would learn them in more detail all the time, because I would need to expand the requisite variety I have for that role. As a consultant, I can know them at a fairly high level to understand some risks. That's the level of knowledge I need to have the variety to survive in those environments. But because it changes all the time, we have to learn new stuff all the time. And that's just part and parcel of it. That's just what we have to accept we have to do. And because of that, it's hard work, right? It seems like there's too much to bite off. There's too much to learn. Therefore, we're never even going to start. So what we do is we do it in small chunks. So we start with the technology we actually work with, learn that in more detail. Do we just know the buzzwords for that technology? Do we just know the name? Or do we know how it works? Do we know how to start up the environment? How far can we take our knowledge of this? If we're already using tools, do we know what all the features of that tool have? Do we know what all the menu items are? That will teach us more about what our opportunities are, what our possibilities are. If we're going to learn how to program, start with the programming languages that you use on the team. Therefore, you've got people who can help you if that's what you want to use. And then you can maintain it within the team. You don't have to learn the programming language that everyone says testers should learn. Learn the one that you're using on the team. And if you do anything at all, just look at where the limits in your testing are. If you are only checking on the GUI and you know that there's a database and you haven't got the skills to look in the database, you have limited your testing, and you should probably learn the technology to look in the database. If there are server logs and you're not using them as part of your testing to check to see whether there are errors happening in passing, then that's a limit in your testing that you can use to drive more knowledge gathering. So this is a cover based on an old Dale Carnegie book. This was his How to Develop Self-Confidence and Influence People Through Public Speaking book. Now, I'm not suggesting, I think you will. If you're testing a system at a more technical level, you will develop self-confidence in the ability to handle new technologies. You will be able to handle anything that people throw at you because you can learn new things and cope with the new systems and changes that are coming in. Now, the reasons that Dale puts forward are, you can win recognition. Now, you probably would. If you start testing at a more technical level and you start finding defects that other people haven't found, you will be recognized for finding those defects. You will gain a better job. You might view your job as a better job because you're continually learning new things. You're diving into more detail. The job itself doesn't have to change. You change the way that you're doing it and continually advancing what you do. I cannot guarantee a bigger income. It has not worked for me. However, you might be the one person whose technical skills take them to a better income level. However, what I'm going to do in this talk is, looking at the experience I've had from technical testing, try and give you more hints on how to do it. What I've tried to do in the first place is just justify it. So really why we're doing this is to try and test the system more deeply, to increase the variety that we have in terms of our test approach, what we can do, where we can observe, where we can manipulate. It's not mine, thank goodness. I did that once. I did a talk. My phone went off. It was the only one in the room. Brilliant. We can find errors that no one else has seen. We can improve our skills and communicate more effectively with developers, DevOps, and other people on the project. We find security issues earlier, but we don't find it by security testing. We find it by doing functional testing and observing at a more detailed level. And the issues just happen to be security issues that would later bite us. And it will, I guarantee, improve your testing because it improves your skill set and improves your flexibility and your variety in how you can handle and test applications. So I'm now going to look at the actual secrets, the actual things that I do. What I've tried to do at this point is justify them. So now I'm going to go through them. Right, now I'm going to start with Buckminster Fuller. Right, Buckminster Fuller was a polymath. He invented a whole bunch of things. He created a new map of the world. He created the Dymaxion dome that you might have seen. This is the last book he wrote. It was apparently the manuscript was on his deathbed. And he basically said, "We are powerfully imprisoned in these dark ages simply by the terms in which we have been conditioned to think." Right? Our mental models of the world impact what we can do, what we will do. If we don't expand those, we will never test in other areas, which is why modeling is fundamental to what we have to do. And again, that's a big thing. So we split it into small chunks. Look at what you're currently doing. Collate all the buzzwords and all the terms in your current environment. Create informal models. We just don't have to be formal models. These can just be lists of terms that you then go and Google to find out what they do. Because the point here is we are modeling to figure out what our limits are, to understand what we know and what we think we know, and what we only know at a really superficial level, so that we can go more deeply into it. Because this is constantly about research and trying to do more things. So this is a pretty simple model of my website. Got my website over here in a browser. There's some messages going back and forwards to a server. If this was the only model I had when I was testing this website, I probably wouldn't be able to do much testing other than just click about on the front end. So what I want to start doing is looking at my system, the front end, what buzzwords do I have in there? What things are involved in there? So I know that JavaScript's involved, but I don't necessarily know where it is. I don't know what events are hooked into. I don't know whether there's cross-browser risks related to that JavaScript. That might be something I go and investigate. CSS. CSS is what we use to style it. CSS is what we use to possibly control the rendering on different devices at different sizes. Do I know what the CSS does? If I don't know how these two things work, if I don't know what these things do, what I'm essentially going to be doing is testing my website on every browser and as many devices as I can get my handle on. But I'm not going to be targeting the risk that CSS might introduce. So again, I might miss it. Even though I'm doing all that testing, because I haven't understood the risk that it introduces, I might not target that specifically. We've got the DOM, how it's rendered on the application. I might use different browser plugins. There's the dev tools. I'm going to show you some of this later on. Do I understand the difference between HTML and HTML5? Do I know which one the website is using? If I don't, that's probably something important for me to learn. And it goes on in terms of, is my application using local storage? If it is, how does that impact me? Is it using cookies? If I change those cookies, what impact does that have on my application? Is it using cache headers? Do I know this? Does this form part of my test strategy? Each of these are things that go wrong with applications. They go wrong with websites. If we're not bringing this into our testing process, we're not necessarily going deep enough. But that's just the front end. There's a whole bunch of other technologies in use here. So at the messaging layer, I might want to start understanding the HTTP messages, and particularly the headers in there. And when I start observing them, do I even know what they mean? Do I know what impact they have? I might have to go down to the network layer and look at the TCP/IP messages. It's rare that I have to do that. I have had to do that on some mobile applications because I couldn't change the proxy and view them. So I've had to observe at a much lower level. I use proxies a lot. Do we know the HTTP verbs? I was once testing an application where I accidentally stumbled across the admin interface. And so I raised that as a defect, so they fixed that. But the way they fixed it was simply to say any GET request to the admin interface would be rejected. But if I changed the verbs to posts, then I could get access to the admin interface. But I was able to do that because I understood what the HTTP verbs are, and I understood tools that I could use to automatically change them. Otherwise, that would have been fixed, and we would have gone ahead with that. When I'm seeing the responses, or am I even seeing the responses, I want to see the responses from the server to know what is in there, to know what message is going back and forward. All of these things we would have as part of our model, and we would have to explore and experiment with. Stafford Beer said in his Designing Freedom book, because Stafford Beer was a cybernetician, the prescription for action is not difficult to understand. First of all, we need better models of the components. As soon as we have better models of our components, as soon as we have better models of our processes, we can then start looking for gaps. We can then start addressing coverage. All coverage is based on a model. Every coverage metric we have is based on some model. If we don't have a model, we don't have a measure of coverage, we can't assess whether we're doing enough or not. As soon as we have a model, we can start asking questions. Now, the three main questions I ask are these ones. Can I observe it? Can I interrogate it? And can I manipulate it? Those are the main things that I do when I'm testing. So if I know that there's JavaScript, how can I observe what JavaScript is coming through? How can I observe what CSS is in use to know which parts of all the CSS files we've got are actually being applied? How can I deep dive and interrogate into the messages that are sent? And particularly, how can I manipulate them? Because if I can't manipulate, I'm not really testing, I'm using. And I need to test things. So I need to change things. So I want to be able to manipulate the HTTP messages. I want to be able to send things to the server to see whether it can cope with the variety that I'm going to give it. And I sometimes have to manipulate it to do that. Well, I always have to manipulate it to do that. But we apply these questions to our model. We don't just ask them in isolation. Because what I'm going to try and get across to you here is, yes, we use lots of tools, but we use lots of tools to help us do these things, to help us answer these questions. Now, as soon as we have tools, we can then look at the features in there to see how much more we can do. So if you've ever used the browser developer tools, have you explored them to see how much other functionality they can give you? Similarly with any of these tools that are listed up here. Now, if I'm in the browser, if the only thing I have available is the browser, and I take a technical view of this, I'm no longer just using the browser. What I'm doing is the browser is my observation tool. So I can then use it to target, change the size of the window in order to target CSS risks, because that will trigger different CSS layouts. If technically I understand that some browsers are based on WebKit and some are not, I might decide to limit my testing because I know they're using the same rendering engine. But they may be using different versions of the rendering engine, so that might not be a valid strategy. So I have to be careful, but I can assess it at a technical risk level. So how can we observe the HTML? Starting at the most basic level, if this is a web application and I want to observe things, how can I observe the HTML? Well, I can look at the page source. The page source will give me an image of the HTML. Now, I appreciate that you can't read it, right? But what this is showing me is it's a syntax view of the web page. And there are comments in there. And the comments, this is my live website. This is me looking at it, and I can see there's a comment in there that's coming from the framework that I use that says, use the .htt access and remove these lines to avoid edge case issues. I don't know what that means. There's some sort of bug in my website for edge case issues that I don't understand that is only hinted at in the source code that I would have known nothing about if I hadn't looked at this. When we start looking through this, we can see, do we understand the difference between the header tag and the body tag? Do we know what the meta tags do? I can see that I'm using a framework. I'm using a tool called DocPad. I can see that I'm using Bootstrap as the basic layout engine for my website. And I can see that the Bootstrap files are coming from a CDN. So they're coming from a content delivery network rather than my server. Potentially that's a technical risk. If the CDN is down, someone comes to my site, those files don't get loaded, the rendering doesn't work, and they blame my site instead of the CDN. This is a technical risk. So I have accepted that risk. And if you spot these kind of things on your project, you can ask those questions. Do we accept this technical risk under these particular scenarios? And you can ask those questions because you've seen the evidence, you've got the information, and you understand what it means. So how else can we observe the HTML? Well, we can use the dev tools. We can inspect the elements, right? And that will show the HTML down here in the dev tools. But not only that, it will show me which part of the main page is attached to that HTML. So I can see the HTML and the rendering part. And I can see over there which CSS is applied at that point in time. So I get a lot more information in context at this point. And I can scroll up and down and analyze it in more detail. But not only that, I can manipulate in the browser. I can change the text in this view. So if I can change the text on the buttons, I can probably delete fields in the forms and then submit forms to the server that are missing information. Can our server handle that? I can change the values in the fields in the form. I can test boundaries that we might never expect. Right? If we have a form that has a date drop down, and the date has January through to December, because there's 12 months, I can edit the DOM to have a month called Bob that has a value -13, and send that information to the server and see if it copes with that level of variety. Now, these tools are in every browser by standard. Right? This isn't unique to testing. We all have access to this. My son has access to this, and he's 11, and I'm teaching him how to use these. We got a box of goodies from Spotify because he found a bug in their software. What he loves doing is going onto websites and changing all the images to look like pufferfish and ugly fish and those squidgy things. Plus, he found a denial of service attack on his school website. So we're learning how to do these things. It's no longer the case that you have to be technically knowledgeable in order to do this. If you accidentally right-click, do inspect, you see something in the DOM, you accidentally do delete, and you submit the form. Your users might do that. Our servers have to have the requisite variety to handle front-end stuff that is now messed up because users can mess with it. Nothing on the front end is safe anymore. So in the browser itself, what else can we do? We can go beyond just the GUI now. It used to be it was just GUI-based. We can see the web traffic. This is a list of all the traffic going through to the server. I can see this in the browser now. I can see that when I hit evotester.com, it loads in a JavaScript file, which then loads in some other files. I didn't know that. That was new to me. That expanded my model of my application. So I can now view, is this a risk? Is this giving me timing issues because I can see the timing down there? All of this is more information that we can use to then direct in our testing. Now, what I can't do here is I can't manipulate this. I can't resend these requests. But I can observe it, and I can interrogate it. I can go in and see what the messages do. I can see what the headers are. I can see all this in the browser. Is it an issue for me that I haven't set any cache headers on this page? I can see it right there. I haven't set any cache headers. So every time I go to this page, I'm bringing it down each time. That might be an issue for me. It might be an issue in some applications. It might be an issue in some applications that we do set the cache header. Do we know that? Do we understand it? All this information here is stuff we can use to learn, to expand our models, to then change the way that we test. Now I can observe the JavaScript. I could see the JavaScript before in the traffic, but we've got a sources library here. I can see the JavaScript in more detail. But not only can I see it, I can set breakpoints, which means that when I use the application, the JavaScript at some point will stop. I can then issue JavaScript commands through the console, or I can change the variables in the watching side here, and I can put the front end in a state that might be hard to get to naturally. So long as I know what I'm doing, I can put this in a state. I can change the JavaScript if I want to bypass the validation rules. We have a lot of flexibility here. So what else can we do? Just trying to wind up in the browser here. Now, I tend not to use the JavaScript performance stuff, but I do use the resources. The ability to look at the local storage, which is new in HTML5, the ability to look at the cookies. Now, what I can't do in the browser is change them. I can't amend them. I can't create new ones. Because the browsers do try and protect us from security issues. And being able to add new cookies, being able to change them, can be a security risk. However, we've got plugins for that. I can add in, edit this cookie, and then I can add new cookies and change them. That's not a problem. Nothing's going to limit the testing that I do. I've got this audit level, which is kind of free testing. It's given me a whole bunch of red issues and amber ones, stuff that I didn't know about on the web page that I might want to address or at least understand to know if they're a problem. We get this stuff for free. In the JavaScript console, which we normally use for issuing JavaScript commands, what I've done here is I've stuck on preserve log, and that means that when I change pages, it tells me I've just navigated to a different page. That's what this blue line that you can't read is saying I've just navigated to a different page. And when I did that, it's then reported in red a whole bunch of errors, a whole bunch of issues that if I wasn't observing through the console, I would miss. I don't know if they're important or not until I investigate them, but by increasing our variety in terms of our observation, we increase our ability to see errors in passing that other people will miss, and we increase our ability to learn stuff. So the browsers also have the ability to help us test with mobile. By clicking on this tiny little blue button in the top left of the DevTools in Chrome, I can enter the mobile simulator. Now, they have a tendency to move this button around, but so long as you know the functionality is there, you can find it. And what I'm doing here is I've set the device to be Google Nexus 4, so it's changed the size of the display to match the size of the Nexus 4. If I choose a different device, it will match that. Now, it's not the same rendering engine that's on that device, but it's an approximation of what it might look like. But what's more important here is that it's changed the user agent. Now, the user agent is a string that's put into the header when we make a request that tells the server what device we're on. So when I make requests now, the server thinks I'm on a Google Nexus 4. So if the server does anything different based on this mobile, I can test that without having to have the mobile. I can't test the rendering validly and know that there's no problem, but I can see how the server responds to these requests. So it's useful to know these things are in there and expand our testing. And the more that we observe, the more you're going to see things you haven't seen before. And I guarantee the first time that you start observing at these levels, you are going to be swamped with information. So you're just going to have to cherry pick different bits to learn more about it. But you can use your Google skills to then find out what it is, because the more that you see, the more that you will model, the more you will understand, and the more you can then use that in your testing, and the more problems you will spot. Now, you can also manipulate, and that's important because you can test conditions that were hard to test before. It's hard to test boundary conditions that when your GUI is locked down. It's hard to... Thing is, I was reading a blog, I think it was this afternoon, where people were using the hidden fields in forms to do SQL injection. Right? The hidden fields, the things that the GUI doesn't render, the things that we don't even know exist, give risks to our back-end servers. And we can then start bringing that into our testing. Or we can at least see what it is. If we have a hidden field that has the total price of our order, and we amend it, and if the server honors that price, that's a problem. Even simple things like that, we found problems like that on websites where we're able to buy things for £0 and 0 pence. Now, you can't do that in the real world because that's illegal. That's called fraud. But on your systems, you can do that. On your systems, you have the freedom to do whatever you want and whatever you need to that application. Now, if I've got a model, I can fill in the gaps. Right? We've already known that all of this happens on the browser end. It doesn't happen in the messaging layer. So I now have to fill in some gaps in the messaging layer. So how do I do that? I already know what question to ask. So I ask Google, how can I observe the HTTP traffic? And Google tells me, Alan, this is how you can do the HTTP traffic. Because what's important here is not necessarily knowing how to do everything, but having a model that allows me to ask the right questions to an expert, like Google. Buckminster Fuller, in 1960, I think, wrote a book about the future of education. And what he said was, in the future, students will simply call up the information they need. They will simply ask, and the information will be given to them. And when they wanted more detailed information, they would have two-way television to discuss this. Things like, this is before the internet, but as far as I'm concerned, he was predicting our ability to ask Google whatever question we want and get the information. He was predicting our ability to have social media where we can ask experts on any topic, any question we want, because we've never been more connected than ever before. And that was in the 60s, and that is why I value Buckminster Fuller and his approach to thinking, because he was way ahead of Back to the Future, who had fax machines in 2015. Now, one of the answers that Google gives back are the notion of proxies. Proxies are tools that sit in the middle where we send the request to the proxy, and the proxy then sends the request to the server, and the response comes back. Now, there's 4 main proxies that I use. Now, I'm giving you the tools simply to shortcut some of your learning. Because if you're just starting with this, proxies can seem quite hard. So if you're starting and you're on Windows, if you pick up Fiddler, that's a really easy-to-use tool that will automatically hook into your networking layer and show you the traffic. If you're on a Mac, if you use Charles, it will do the same thing. In fact, Charles will do that in Windows as well, but Charles is shareware, so you do have to pay for it over a certain amount of time. Fiddler is free. The more technical you get, I run Fiddler in a virtual machine on my Mac. Just a little bit extra knowledge allows me to do that. Burp Suite and OWASP Zap are essentially security testing tools. All of these tools do something slightly different. Their basic functionality is the same, but the security tools help you go a little bit more deeper into the application. So with the proxies, I can observe the traffic going back and forwards. We can export the traffic for later analysis. I was working on an API application, and what we did is we took all our automated tests, fed them through a proxy as they were testing the API. Then I extracted all the calls that were made, then processed it to see what requests we were making, comparing it against a model so I could check our coverage of what we were testing against the API. So I could see which URLs we were hitting, whether it was all the URLs in the API, whether we're hitting them with all the verbs that we needed to, whether we're doing the variable exploration that we needed to. We can amend the requests. So we can have a request come in like I did when I was looking at the conference tool. The request was there, I amended it and sent it through. That allows us to test specific conditions. That allows us to test conditions out of sequence that would be hard to test otherwise. We can fuzz them. Fuzzing is a security thing where we take a request, we identify variables in the payload, and we fuzz over them. We resend the request with different instantiations of that variable. It's used very often for SQL injection. So you have a big list of SQL injections, you choose the payload, you send the request to the server with all the little SQL injections and see what comes back. When we do testing, we can use that to set up test data. I can take the request that creates a user, I can fuzz the username and password, and I can create a whole bunch of users without having to script it, without having to know how to program. So soon as we know what this functionality is, we can find alternative uses for it that improve our ability to test and give us more control over our testing. Again, we can set breakpoints and amend them. We can automatically change the requests. We can simulate slow networks in some of the proxies. So if you're working on mobile devices, you can simulate a slower network by going through the proxy. We can supply different responses. I was testing a game. We found an error in the JavaScript. Rather than deploy the JavaScript to the server and impact anyone else, I got the JavaScript first, had the proxy send me the JavaScript from my local desktop rather than the server so that I could test the new version in isolation of everyone else. And we can chain proxies. Because they do different things, we can use them in combination. So I can send the requests through the different proxies to improve my ability to do things. Fiddler comes with a great feature called autoresponders so that we can simulate 500 errors and 400 errors without having to change the server. Things that would be hard to do, we can do with a man-in-the-middle tool to help us. This is a basic setup that I use when I'm doing mobile testing. There's my laptop on top of a Buckminster Fuller book, because that's the kind of laptop stand I have. There's the mobile device. It's going through a Wi-Fi, very small portable Wi-Fi hotspot connected into my laptop. which means that I can monitor the traffic on my laptop in an isolated Wi-Fi environment, rather than try and take all the traffic off the proper guest network. When it's going through my laptop, I can more easily send the mobile traffic through a VPN. So I can have a VPN connected to America, and then I can test geolocation. Now, you can set VPNs up on mobile devices, but it's a pain to have to set up on each mobile device each time. So by feeding it through a laptop where I can set it once, I can then test on multiple mobile devices going through a different geolocation at the same time. I can have proxies running on the laptop and send the requests from the mobile device through those proxies and start debugging the tool, debugging the request there. Now, the other part of my testing model is reflection, the ability to think about what we're doing, because then I'll spot gaps, then I'll identify intent to then try and test in more detail. This is an important part, the reflection part, because this is where we identify what we're going to do next in terms of improving our learning. So I've got lists of some recent tools I've used in terms of APIs, Postman, different plugins, proxies, whatever else. All the slides will be available later on. But the point is not the list of tools, right? The tools are a side effect of the thinking process that leads to me wanting to do something. In order to manipulate the API, I need a tool to do that. In order for me to manipulate the cookies, I need a tool to do that. But it's the question that I ask, knowing that I have that intent, because that is part of my model and I've expanded my testing, is the point. Now, these are the books that I ripped off during this. I just love the old-fashioned covers. But the reason I put them up there, again, is a self-help talk. This is work that you have to do. And if you do put in the work, and you do pay attention to these 5 principles, at this point I'm going to be the motivational self-help speaker, 5 keys that are going to unlock your ability to test anything at all, to increase your salary, to get a better job, to improve your prospects in life. If you can learn how to model, you can learn how to observe the traffic, you can learn how to think and reflect on what you're doing, and you can learn how to interrogate that system and manipulate it. And never view manipulation as a bad word. It's not an evil word. It's what we do as testers. We manipulate the system. We have to learn how to do this manipulation. And if you can do that, you will improve your technical testability and your ability to test. So thank you very much.